Hey everybody, Mr. Kowalczyk here with Unit 5, Lesson 3. In this one, we're going to do Standard 9.3. I can use the properties of trapezoids, isosceles trapezoids, and kites to identify and solve related problems. All right, for today's opener, what can you determine about the angles in these two quadrilaterals? So we've got this one here, and we have this one here. Notice that these two sides, BA and CD, are congruent, and BC and AD are parallel. Same thing here. We have two sides that are parallel and two sides that are congruent to each other. So pause the video, see what you can figure out about the angles in these two quadrilaterals. All right, hopefully you pause the video and let's talk about what's going on here. So in order to determine what's going on with each of these angles, we need to realize that here we have two parallel lines and we have two angles that are intersected by a transversal right here. So we know for a fact that this angle here and this angle here are going to be supplementary because this is our transversal and we have two parallel lines here. So we have same side interior angles right here. Because this is 115 degrees, that makes this one 75 degrees. No, sorry, 65 degrees. 65 degrees. Okay. Now we don't know what's going on with these angles here, but we can't necessarily figure that out because we don't have a common transversal that goes across from each one. Now with 50 degrees here, same thing is true that this angle S and angle P are also going to be supplementary. That makes angle P 130 degrees. All right, hopefully you got that. All right, so for notes, today we'll take notes on the quadrilateral family tree we began yesterday. We'll learn about three shapes today: trapezoids, isosceles trapezoids, and kites. So the last three shapes on our quadrilateral family tree. So let's go ahead and jump back into our quadrilateral family tree and fill that out. So if you could pull that one up, take a second, get to that page. If you have some other colors. So first off, we're going to do our definitions. Definition of a kite is going to be a quadrilateral with two pairs of adjacent congruent sides. So what that means is that two sides that are right next to each other are congruent, and two sides that are right next to each other are different from the other sides, but also congruent to each other. That's our definition of a kite. A trapezoid, definition of a trapezoid, is one pair of parallel sides. That's it, only one. A parallelogram has two sets of opposite and parallel sides, whereas a trapezoid has exactly one pair of parallel sides. Okay. And an isosceles trapezoid is a trapezoid with one pair of parallel sides and one pair of congruent legs. And I use sides and legs here differently because the top and bottom are going to be the sides that are parallel, and the legs are not the same sides, but they're going to be congruent to each other. Okay. So similar to an isosceles triangle, but in this case it's a quadrilateral. That's a definition of an isosceles trapezoid. All right, let's flip on over and fill out our ways to prove for kites, trapezoids, and isosceles trapezoids. Let's start with a kite. All right, now a kite, like we said earlier, is going to have two sets of congruent adjacent sides. Okay. Now, what else is a kite going to have? A kite is going to have some special diagonals. Now the diagonals are perpendicular to each other, and the diagonals are going to create one bisector. So this one here is going to be split in half. So this diagonal is split in half by the other diagonal. The last thing that happens in a kite is that this diagonal that also splits in half this diagonal here, what this diagonal does, the vertical one in this situation, is it splits the angles in half. It bisects the angles as well. So it's a perpendicular bisector of this diagonal, and it's also a perpendicular bisector of these two angles up top and up bottom. These are not bisected, so don't fall for that, okay? So the diagonals, one of the diagonals is a perpendicular bisector of the other, and it bisects the top and bottom angles of the kite in this orientation. Okay. All right, now next we have trapezoid. Let's go down to the trapezoid and talk about that. We already know that a trapezoid has one set of parallel lines or pairs. Okay. For the trapezoid. The other thing that we know about trapezoids is that the adjacent angles to the parallel sides are going to be supplementary. So we'll call this trapezoid A, B, C, D. So then the measure of angle A plus the measure of angle B equals 180. And the measure of angle C plus the measure of angle D also equals 180. We know that because they're same side interiors with our transversal and our parallel sides. Same side interior, transversal, parallel sides. Okay, so that's what we have for our trapezoid. Our isosceles trapezoid gets a little bit more complicated in this situation. So for the isosceles trapezoid, all of the same things for the trapezoid apply. So all of these things apply as well. And we add to that we have congruent legs and parallel sides. Okay. Parallel sides, congruent legs, in an isosceles trapezoid. We also know in a trapezoid that the lower base angles, the ones that look the same, are the same. And the upper base angles are the same also. Congruent lower base angle, congruent upper base angle. Okay. We also know something cool about these, and that's the diagonals in an isosceles trapezoid are congruent to each other. So the whole length of this is congruent to the whole length of this. So we have congruent diagonals in our isosceles trapezoids. All right, so these congruent brackets look a little cluttered. I apologize for that, but maybe you come up with a better way to mark it. So that's how to prove an isosceles trapezoid, a trapezoid, as well as a kite, okay? Now remember, in our quadrilateral family tree, what we have is we've got two different sides. Today we're doing the kite, trapezoid, and isosceles trapezoid side. Yesterday we did the side over here with the parallelograms. So for kites, it only has one shape in that branch. For isosceles trapezoids and trapezoids, there are two shapes in that branch. So everything that's true for a trapezoid is also true for an isosceles trapezoid because it's beneath it on that isosceles, or excuse me, on the trapezoid branch. So everything that's true here is also true here, but it doesn't go the other way, right? The stuff that's true for the isosceles trapezoid isn't necessarily true for the trapezoid. So just keep that in mind as you're answering today's question. All right, so let's go ahead and answer 2 of today's questions that we've got. First, we'll do number 1, and then we'll jump into number 7. So what properties do all trapezoids have? We're going to do these 2 together. First off, trapezoids. Trapezoids, all trapezoids? No, not all trapezoids. They don't have congruent diagonals. Isosceles trapezoids have congruent diagonals. Do all trapezoids have 4 right angles? Nope. No, they don't. If they had 4 right angles, they would be a rectangle. And then they would have 2 sets of parallel sides, so it wouldn't be a trapezoid anymore. 1 pair of opposite sides that are parallel. That is true. DC and AB in this diagram are parallel. Congruent opposite angles. Well, we know that that's not true. They all don't have congruent opposite angles, so that can't be it. So therefore, C, by process of elimination, has to be our correct answer. Okay. All right, now let's skip over to 7, and we'll do 7 together, and then you can hold off on the rest for tomorrow in class. All right, trapezoid ABC is an isosceles trapezoid. So first thing I'm going to do, I'm going to illustrate that. And when I illustrate it, I have to remember to go around in order. I can't jump around A, B, C, D. So I got to follow this particular order. The measure of angle C is 35 degrees. 35 degrees. What is the measure of angle A? Well, if I look back at my parallelogram family tree and I see my isosceles trapezoids, angle C is down here and angle A is up here. So what that tells me is that angle C and this angle up here, which is angle B, are supplementary. That also means because angle B and angle A are congruent, that angle A and angle C are supplementary. So in this situation, angle A plus angle C has to equal 180. So then the measurement of angle A plus 35 degrees equals 180. Therefore, I can subtract 35 from both sides. And the measurement of angle A is equal to 180 minus 35 gives me 145 degrees. Put my box around it, and I'm done. All right, y'all. We'll stop there for today. Good job taking notes. We'll see you in class next time and do the rest of these practice problems together. Have a good day.